go, Chad. Good. Okay. All right. Is this working? Is this working? Okay. All right, let's go. Colin P. Good morning, Fraser. If someone dies during a mission while on the surface of the moon or Mars, will the body be back to Earth or buried where they died? If it's a death during transit, will the body be brought back or buried in space? Do the families have a say in this? So this is something that unfortunately NASA has spent a lot of time thinking about because they need to be prepared for every contingency. And so there are a bunch of different places that astronauts can die over the course of a mission. So let's start with say they're going to the moon. Oh no, let's say they're in orbit in orbit around the International Station. So let's say they're in orbit on board the International Space Station. If that happens, then the astronaut will be put into a body bag. They have them on the station, and then they will be returned back to Earth on the next return mission. Now, I don't know whether they would necessarily cut the mission short, but they would definitely bring the astronaut back down to Earth. If the mission happens, say someone died during the Artemis 2 mission, someone's on the way to the moon or on the way to Mars and dies during the mission, then they would be kept on board the spacecraft and would do a complete journey, say around the moon, and then be returned as one of the crew on the return mission, which is kind of, would really be sad if the, two of the astronauts would survive. They're trying to complete their mission, but one of their astronaut coworkers, person they've trained with for years, is there on the spacecraft and has passed away. If they go to a place like the moon, then it becomes more complicated, right? If you're down on the surface of the moon, and you're going to be, there's enough cargo capacity on the spacecraft, the ascent vehicle, to bring you back, then you're probably going to be bringing the astronaut back to Earth. But if you're on Mars, this is a bit of a tricky problem because, there are going to be challenges bringing the body back from the surface of Mars. If you've got an ascent vehicle, you're already going to have room. It's going to be pre-planned. And so maybe you will bring the astronaut back from Mars. But if the decision is made to not, then you need to cremate the body on the surface of Mars because there is the potential for, all of the microbes that are on the human body to make their way into the local ecosystem. So you would not see a burial on Mars because that is a risk of, a biological contamination of Mars. And so you would see either they would have to incinerate the body or bring them back to Earth. And these are procedures and policies that have been developed by NASA. They've sort of thought through every part of this. And so, no, the family wouldn't have a choice in this. And especially, if it's something that is relevant to spaceflight, then obviously they would want to be able to do an autopsy, be able to figure out what had caused their death. So there would be, there would be scientific value in getting this body back to Earth. But, it has not happened yet. Obviously, we saw the loss in the Challenger. We saw the loss in the Columbia. There was the Apollo 1 fire. There was a Soviet return, but we haven't had the situation where somebody has died, say, on the moon or Mars or in orbit yet. So far, this is just a purely theoretical issue and not something practically that has happened. But it's inevitable. Space is hard and scary, and we've watched enough science fiction that's told us how hard and scary that it is. All right. Hey everybody, welcome to the weekly question show here Monday on my channel. So just one point, if you're watching this, I want to get this out in advance. I'm going to be doing another question show next week, and then I'm going to be off for 2 weeks because I'm going to be in Japan, and then we'll be back. So we've got overtime episodes that we're going to run. If you're just watching our episodes on every week, it'll feel seamless, but just keep that in mind that don't show up for the live stream after May the 11th. So a week from Monday. That's it. So if you're wondering what it is that you have stumbled into, this is my weekly question show where the community hammers me, peppers me with questions about space and or astronomy or whatever's behind me on the shelf. And I will try to answer them. A few ground rules, of course. I am a journalist, not a scientist, and so I cannot provide you with original opinions or evaluations of scientific theories. I can merely restate the scientific consensus. I try to give emphasis to the people who've never had a question answered before, so if that's you, if you're just like sitting there watching, listening, and a question is popping into your brain right now, go ahead, put it into the YouTube comments. You don't have to get fancy about it. You don't have to, you can just have a question mark in your question or use the who, what, where, when, why, how, and that will trigger the system to grab that and put it into the database so that I can then see all of the questions that have been asked. And sometimes it's a little overzealous in what it thinks is a question. But yeah, go ahead and do that. And only do it once. You don't have to do it a bunch of times. We got it. And then the last part is obviously, I only am able to get to a fraction of the questions that get asked during this episode. So it lasts for 2 hours and I typically get through 60 plus questions and, a few 120 get asked. So I do what I can as quickly as I can, or I take my time on the questions, who knows? But also, we get a lot of the same questions. And so I try to mix it up. I don't know the answers to a lot of questions, or it may require too much math and homework and stuff for me to be able to do just during a live show. So just keep that in mind. All right, good. So go ahead, put any questions you have, and we will get cracking. Neil von Holtum. What happens if a country claims Mars as their own? So almost every nation on Earth has signed something called the Outer Space Treaty. And this is a guideline, a worldwide guideline for how the nations on planet Earth are expected to behave in space. And there's a lot of rules in it, mostly about how you're not allowed to put nuclear weapons in space. That is the big no-no. That is if you look at the Outer Space Treaty, the thing they're really concerned about is orbital weapons. And for good reason, because if you launch a rocket that has nuclear warheads on it, and you can have that go above another country that perhaps you have a beef with, then you can drop missiles on that country in just a minute or two. And so there's no warning. You can just sneak attack some other country and destroy them before they have a chance to respond. And instead, we have the perfectly sane, very rational, you have to have your nuclear weapons on submarines that can't be found, or in silos in the middle of the Midwest, or launched on airplanes, and that will give people 20 minutes of warning before the apocalypse, and they can decide which of the horrible possibilities they want to consider. So we are very civilized. But the Outer Space Treaty also has a bunch of other provisions in it, and they talk a lot about how no nation may claim any place in space. So you cannot own the moon, you cannot own Mars, you cannot own Alpha Centauri, you are not allowed to own any of that. So that is the framework of the Outer Space Treaty, and all the nations that have the ability to go to space have signed this treaty. That said, there's this sort of term in law, possession is 9/10 of the law, right? That if a nation was to try to violate the Outer Space Treaty and actually set up shop on the moon and say, we own the moon, then they're going to have problems down on Earth because, if it's China, United States, Canada, right, whatever, you still have this global economy, these interactions, these trade flows that are going back and forth, laws, regulations, and there's a lot of pressure that various nations can put on you to get you back in line with the Outer Space Treaty. They can do embargoes. They can kick you out of the global financial system. They can sort of remove investments. They can switch currencies. Like, there's a lot of economic damage that the rest of the world united can do to any country that is trying to violate the Outer Space Treaty. Same thing with Mars. Right? If the United States says we're going to own Mars, then the rest of the world can say, no, you don't. And as long as you keep saying that you own Mars, then we're going to punish you here on Earth. And this is where you keep all your stuff. Where it comes to the sort of possession is 9/10 of the law is that if you can actually go to Mars, let's say some country goes to Mars and actually sets up a city and says, no, don't worry, we're not trying to own Mars. And then they say, okay, actually, Mars is really profitable. We now own Mars. Mars is part of Japan. And the world goes, well, we're going to hammer Japan economically. And Japan goes, I don't care, whatever, do what you want, because Mars is more profitable. And that people will have to actually decide whether they want to go to Mars and stop them from owning Mars. And that is very difficult. And so, when we think about sort of the plans of people like Elon Musk, right? He wants to go and build a city on Mars. And if he went to Mars, built a city, the city was self-sufficient, and that they decided to cut off all ties with Earth and declare their own sovereign country of Mars, their own planet. It would all be on whether or not people were willing to send warships and Marines from Earth to Mars to solve this problem. And it is very expensive. Now, there's no reason to do this because there's no profit to be made on Mars. And so we wouldn't expect anybody would ever actually do such a thing. So it is a violation of the Outer Space Treaty. But then, we see international treaties get violated all the time. And there are no consequences for violating international treaties. So the reason that nobody is going to try to claim Mars is because there is no value in it. There's nothing to be gained from saying that you own Mars, apart from the bragging rights and a lot of pissed off neighbors on Earth. Duty. Have the Greeks signed the Outer Space Treaty? They called dibs 5,000 years ago. Okay. Mike D. Isn't this The Expanse? Yeah, I mean, you can imagine this future where somebody finally figures out an economic reason for Mars. That isn't just a giant pit in space that you have to pour money into forever. Because that is what Mars is today. And so any nation that tries to go to Mars and try to set up shop and build a city is just going to be dumping money. It is the equivalent of buying a boat. Anyone who's ever bought a boat, the way it's described is it's a hole in the ocean that you pour money into. Well, if you want to own Mars, it's just going to be a hole in space that you're going to be pouring money into. You're going to be sending replacement parts and propellant and food and new colonists. And then you're going to be bringing home nothing. There's nothing on Mars that we don't have here on Earth. But you can imagine some far, far future, hundreds of years from now, where the gross domestic product of the entire solar system has grown to the point that some base on Mars has figured out how to be economically sustainable, fully self-contained, and capable of cutting ties with Earth. And And this is what happened in The Expanse, that Mars was trying to, the Martians were trying to terraform Mars. The asteroid belt, the Belters, were declaring their own sovereignty. Earth was dying essentially because of climate change and overpopulation, and was just becoming a very bad planet. The reality, of course, is that Earth is so much better than, the worst possible Earth is better than the best possible Mars. That you could go to Antarctica in the middle of winter and it would be a more hospitable place than Mars near the equator on a nice, warm, sunny day. So it's going to be really tricky. It's going to take a lot of technology for us to not make these places just instantly kill us, right? Whether it's an asteroid, whether it's Mars, whether it's the cloud tops of Venus, the Terminator on Mercury, the moon, any of that, all of space is just incredibly hostile and beyond our technology for the foreseeable future. And so we'll only be the places we can go to explore. But there will come a day when our technology has trivialized living anywhere in the solar system. And then perhaps people will have those conversations. But yeah, that's The Expanse. Posthuman Fraser, if you want to fall asleep, do you count planets? No, I put on a YouTube video to listen to like a normal person. Gig Boss Man. After 53 years, how far along would we be on the moon? A moon base 40 years ago, private moon cruises, etc. What say you? I think we are exactly where we are supposed to be on the technology curve of exploring the cosmos, of settling the solar system. Yes, human beings first set foot on the moon in 1969, which is 57 years ago. Crazy, right? That a nation pulled together all of the technology, the engineering, and sent humans to the moon and back safely, and did it 6 times, and then stopped doing it for 53 years. That is sad. But it was incredibly expensive. If you go back and you look at the amount that the United States was spending on NASA during the height of the Apollo era, it is many times more what they're spending on space exploration today. Like the budget of NASA, I think it was $350 billion in inflation adjusted money for them to do the Apollo program. And it was $500 billion or so for the Mercury, Gemini, and Apollo programs. So for that, like 10 years, 15 years that they were doing all of those missions, it was a lot of money. And especially for a nation that didn't have as much money at the time. So nobody has the stomach for that. And there were other priorities. They went and moved to the space shuttle, and they moved to Artemis, and here we are now where the technology is starting to make things cheaper, where we've got reusable rocketry, we've got incredible computers, new material science, a much better understanding of keeping humans alive in space for long periods of time. But we had to go through the space shuttle era, the space station era, and the reusable rocket era, and now we're in the let's maybe go back to the moon. And so it would have had to have been a fundamentally different world at the time. And if you've watched For All Mankind, they tackle this question exactly, which is that, what if the Soviets got to the moon first? How that would create a true space race, and then the Soviets and the Americans would be battling back and forth, and who knows what would happen. And I don't know if that's true. Like, I just don't think any nation has the stomach to spend that kind of money forever, just to keep spending that amount of money without some reason. And as soon as there's some other issue that they need to spend their money on, wars, pandemics, new technology, housing crashes, bailing out billionaires, artificial intelligence, who knows, then the priorities shift and change, and there's no interest in that. And so NASA's funding has remained roughly the same, roughly in the kind of $20 to $25 billion mark for decades now. And that is a fraction of what it was back in the Apollo era. But And so I have to kind of imagine, like, I have to put myself into this place, which is that every politician is space pilled. They love space. It is like it's the Kerbal space program. And you've got this incredible, exciting, enthusiasm for space exploration. People have decided that they no longer want to fight wars anymore, and they just want to invest in really cool space research, trade, getting along with each other, solving the world's climate problems and energy problems, and developing the technology to go to space. In that world, in that dream world, then you would see something that would look very familiar to us today. I think that we would have a base on the moon, a permanently established base on the moon. We probably would have seen the first human explorers go to Mars by this point. We would probably see some human missions that have gone to asteroids, but it wouldn't be the expanse. It would be, there's a station on the moon, kind of like there's a station down in Antarctica. There's just a few tentative steps on Mars. The first humans have gone to Mars at this point, and tentative exploration into the asteroid belt. But it's, it will have been delivering and demonstrating all of this technology that will trickle down through the rest of our society. And again, you've got to kind of go watch For All Mankind. Like, they did a really great job of just considering what space exploration, or just, better medicine, technology, who knows. But I think the key thing is that we would not have unlocked the economic engine for space. And that's the key. That, the thing that you need is for space to pay for itself. And in fact, to drive revenue. Once you get that, then the whole endeavor, then it's a flywheel that spins up. And we probably would not have found that flywheel yet. So it would have continued to be this expense. And every year, governments would be like, why are we spending so much money on space exploration? We should be spending this money on why are we spending this much money on space exploration? We should be spending this money on Earth. We have so many problems on Earth. Why are we sending people to space? Right? That is the conversation that you have when there isn't an economic incentive to do this. You don't see that as like, why are we spending so much money digging oil from the ground when we could be spending that money fixing problems here on Earth? Right? Like, people are just like, because we make money. That's why we do it. We don't have a because we make money yet for space exploration. And we may never. Right? It could be hundreds of years before we figure out an economic reason to explore space. Slowboy Fuel Pump. What if the answer to the Fermi paradox is that we are them? Whoa, dude. I don't understand what you're saying. So are we the Fermi paradox? Are we the aliens? Is that what you're proposing? So even if we are, if we are the aliens, and this is kind of like a civilization wondering where they came from, and someone going, what if we came from other places on boats and stuff? And then they go and they dig down and they find evidence of boats and things like that. Well, we don't see any evidence of the boats, of the spaceships, of the things that we might have used to get here from other star systems. Now, we haven't completely explored the solar system, so there could be evidence of the spaceships out there in the asteroid belt, but we have really well mapped the surface of the moon down to tens of centimeters, that if there was anything on the moon, a monolith, right, Apollo landers, we can see them. If there was a monolith, we would see it. There are Apollo landers, we can see them. So that's the kind of scale. It would have to be something very, very tiny, very small ships. Now, tons of stuff could hide in the asteroid belt. We have barely begun to explore the asteroid belt. So, the asteroid belt is like the bottom of the ocean. Maybe their spaceships are down at the bottom of the ocean. Huh. I just invented a conspiracy theory. You know why nobody is exploring the bottom of the ocean? Because that's where we kept the spaceships. But yeah, but we know that human beings are related. We share a common ancestor to great apes, to cats, to fungi. Like, we know that we fit into the tree of life here on planet Earth. That if we go out and we find other humans out there in space, we're going to tell them that they came from Earth, because we know we can trace our lineage back to whatever was the first life form on Earth. And no one else is going to be able to do that unless they can. And that would be super weird, because you wouldn't get humans on every planet. You would get different things evolving depending on the scenario. So yeah, that's how we know that we started here, and we don't see any evidence that we've gone out to anywhere else in the galaxy. But if that was the question you were asking, it was kind of vague. Dan Chappie, if the moon was like a second Earth, would our space technology be way more advanced at this point? Yeah, absolutely. Right. So, if Earth was a binary planetary system, and you had two Earths that were orbiting around a common center of gravity, and they were going around the sun, and they were identical. They were the same size, same mass, same gravity, same atmospheric composition, which would be tricky because, our atmospheric composition comes from life. And if there was life there, and life had maybe been spreading back and forth, panspermia-ing from Earth to other Earth and back and forth, then and only, say, an intelligent civilization, only humanity had evolved here on planet Earth, then we would absolutely be going there on a regular basis, because it would support human habitation. And the best example of this is like back in the age of exploration. Think about in the times, the 1400s, 1500s, people were sailing around the world. You had Magellan. They were going to these various places around the world on a little boat. And if they needed more food, they fished, or they stopped at a forest and they picked a bunch of stuff, or they stopped at a village and they purchased food, or stole it. If they needed water, it rained on top of them. If they needed to breathe, they just breathed, right? If they needed more trees to repair the ship, they could stop and get all the stuff they needed. So all of the supplies that they required were just there and available. But we won't have any of that in spaceflight. Now, there might be, later on, our technology will allow us to pull in the resources that we require from some other world, whether we're going to use regolith for building material or whatever. But really, every place that we're going to want to go in the solar system is Antarctica times 1,000, right? The worst parts of Antarctica times 1,000. And we're going to have to live there. But if there was this other Earth right over there, vegetation, maybe shared a common ancestor, and we could get there. And then once you're there, then you can cut down trees and drink the water, and, and introduce Earth's animals. Then we would turn this into the other Earth, and then there would be trade back and forth, or at the very least, there would be people commuting back and forth from these two planets once you had a foothold. So yeah, it would be, it just comes down to, are the places that you're going habitable? Which they are not in the solar system. If they are habitable, then you have a toehold, then you can continue on and grow a civilization out of almost nothing. This is a thing that human beings are very good at. But we need to be able to just breathe, drink water, find food, mine metals. These are the things we need to be able to do. And right now, all space exploration is going to require us doing that stuff the hard way. Klebsky, what's your favorite part of space reporting, and where does your interest lie most? Technological advancement, cosmology, particle physics, etc. So the thing that I like the best, and this is a very kind of weird, ephemeral concept, so kind of stay with me here, is I like clever solutions to difficult problems. I like new technologies that will answer long-standing mysteries. I like when people have this kind of eureka moment where they realize that something is caused by something else, and then they perform an experiment to figure that out. And so, when you think about the kinds of stuff that I often report on, I'm often reporting on new observatories. I'm reporting on stuff from the NASA's NIAC Awards, where you've got these really kind of out there ideas that could maybe solve problems. I am really excited about the bleeding edge of just technology, space exploration, science in general, the discoveries. And so it isn't a very specific thing. Like, this is a very general thing that I am excited about that can then be applied to almost every part of this field. That, when I'm looking through the kinds of papers, and someone says, the advanced technology telescope, a way to perceive the cosmic microwave background radiation from the far side of the moon. And someone has gone through and done the math and figured out that the far side of the moon is a good place to put a telescope that will allow you to see the cosmic microwave background radiation. Like, that's catnip to me. And I want to report on that. I want to find that person. I want to ask them questions. I want to understand the research that they're doing. I'm quite excited about little red dots. I'm quite excited about the Vera Rubin mission, because it's just going to be this next level advancement of what we're able to see in the night sky. And that is the through line. And that's the through line for everything that I'm excited about and the kinds of stories that I choose. And, my role at Universe Today as the publisher is that I'm often suggesting the stories for the writers to report on. I'm every day going out and finding all the stories that meet my criteria, my filter, and then I hand them out to the writers. And so often the stories that we're publishing on Universe Today come from stuff that I'm excited about, and hopefully that sort of comes through. And then we talk about it on Space Bites as well, and then the interviews that I do as well. So it's funny. I don't have any. It can be applied to cosmology. It can be applied to astrophysics. It can be applied to technology, space exploration, anything. It just needs to fit into this specific sort of slot in my brain where it's solving novel problems or making interesting discoveries. That's what I'm most excited about. And I love it. Like, I just love it. It tickles my brain in a way, and especially when I talk to people and I start to understand, you could bleed off vapor from the outside of your spacecraft as another form of a heat shield, right? And like, yeah, that would totally work. And you've done tests in the lab. Yeah, we've tested this in the lab, and it works, and it saves us weight. That's the kind of stuff that I love. Web Fiji, I don't understand why people say that you can travel at the speed of light. You can reach any place in the universe instantly. Why? Won't we just travel 186,000 miles in a second? So you're correct that if you could travel at the speed of light, then you would, from an outside observer, be moving at 186,000 miles per hour, or just shy of 300,000. You would be moving at 186,000 miles per second, or just shy of 300,000 kilometers per second. But when you take into account the relativistic, the time dilation, then the faster you go, the closer you get to the speed of light, 99.999999, keep going percent the speed of light, then the distances in front of you shorten, and time dilates, and you experience farther journeys in shorter amounts of time. And so you could travel in a human lifetime, in 10 years, in 15 years, billions of light years from your perspective. it would only take you a couple of years, and you could travel all the way to the edge of the observable universe in a decade. If you could travel at 99.999, keep going with the nines, percent the speed of light. You're not going the speed of light, you're going almost the speed of light, and you have gone 46 billion light years. Now, observers on Earth have had to experience all 46 billion years. So they are 46 billion years older, but you're 10 years older because of time dilation. So I think that's what people are talking about when they're describing that. And this was handled sort of just a little bit in Project Hail Mary. I don't know if you've seen Project Hail Mary, but he has to travel to Tau Ceti. It is like 11 light years away, but the journey only takes them 8 years, I think, or 6 years, because they're moving at relativistic speeds to get there. They're not going light speed, but they're going fast enough that they experience less time because of time dilation. Raby, would there ever be a point where humans decide to try to panspermia on Mars? I mean, you could say that we've already tried a panspermia on Mars. Every time we bit my lip. Every time we send spacecraft to Mars, they're covered in Earth bacteria. And so we know that there are various forms of Earth bacteria. They're hardy enough to withstand the process designed to kill them, to get them off the spacecraft. They radiate them, they heat them, they cool them, they expose them to vacuum, and yet they then travel through space for a year, land on Mars, and they're still alive. And theoretically, if they find the kinds of conditions that would make them happy, they could restart and keep growing. So we've already done this. There are microbes from Earth that are asleep on Mars, waiting for the right habitat to awaken and dominate the local ecosystem. So we've already done a panspermia. But when people talk about these ideas of terraforming Mars, then that, one big offshoot, one flavor of that is that we would use very hardy Earth life forms as a way to jumpstart the process of trying to make Mars more habitable. You want to thicken the atmosphere. You want to regulate the temperature. You're going to want to have life give you a hand with that. We have lichens, we have mosses, we have fungi, we have cyanobacteria, archaea. There's a lot of really extreme life forms that will get the process started. And then as conditions improve, then more and more life forms will be able to come online and be able to participate in this process. And so isn't that panspermia, right? Where we are spreading Earth life intentionally to Mars to try and make the planet more livable. Would fungi grow in regolith? Yes. In fact, researchers are developing methodologies to build bricks on Mars out of regolith and fungi. So you would have a bioreactor on Mars, something that was was brick shaped, and you would put into it various fungi and you would put various growth factors for the fungi, the food that the fungi needs, and it would grow its mycelium networks and would solidify this brick into this combination of regolith and dried mycelium. And then you would be able to use this as building material. They've also have bioreactors they're building with, say, bacteria. So there's a lot of ideas on how we can use life to make things on Mars. So it's not just digging up bricks of regolith and baking it and then turning it into a building material, but actually because then you could do things like repair. You could have, parts of your habitat are cracked. You can actually stimulate the fungi in the wall to help repair it, which is pretty cool. So there have been NIAC awards donated, or there have been NIAC awards that have been awarded for this kind of thing. So people are thinking about how we can use bacteria, fungi, other life forms to help aid in building construction materials and stuff on Mars and the moon. Frosty Winnipeg. I always thought the universe expanded at the speed of light. Did I learn something new? So the universe doesn't expand at the speed of light. The universe expands depending on, so like the universe is expanding. I don't think of a good way to describe this. All right. The universe is expanding, but how fast the universe expanding, but how fast, let me just one more time. Sorry, Chad. The universe is expanding, but how fast the universe is expanding just depends on your perspective. Which parts of the universe do you want to measure that they are moving away from you? So the sort of main measurement of this is called the Hubble constant. And this is, roughly around 70 kilometers per second per megaparsec. And what that means is that if you have a square on a side and you're looking at a region that is 1 megaparsec away from you, which is about 3.3 million light years away from you, then that region is moving away from you at 70 kilometers per second. But if you double that distance, so now you are 2 megaparsecs away, so you are now 6.5 million light years away from that place. Now that place is moving away from you 140 kilometers per second. And so eventually you will make a cube that is big enough that the region on the other side of that cube is moving away from you at the speed of light. And then you'll find a place where that is moving faster than the speed of light. And I forget the exact number. It's about, it's a couple of billion light years away from us is this line where once you go beyond that, then regions of the universe appear to be moving away from us faster than the speed of light. But you can't move faster than the speed of light through space. Only space itself can be moving faster than the speed of light from some other vantage point. Jimmy James, can you see the snowbirds practice where you live? Yes. So I live in Courtenay, British Columbia, and we are connected to another town called Comox. And Comox is the West Coast base, military base for the Canadian Air Force. And so they do this is the summer training area for the Canadian snowbirds. And they're like a formation flying acrobatic jet team. And so, yes, all summer long, we experience the snowbirds, these jets flying in formation overhead all the time. I've moved a little bit out of town now, so I don't see them. They used to just fly right overhead all the time. And then they would do various air shows and stuff. So yeah, we're very familiar with the snowbirds here. Dougal, have you been coerced into getting a 3D printer yet? I'm pretty close. Yeah, a lot of people are recommending the Bamboo A1, but it might be a little out of my price range. So I'm definitely thinking about it. But there was like a YouTube video I was watching this morning where this guy was building a little cabin on his property, which is the thing I'm thinking of doing. And he was like 3D printing various parts of the cabin. It was like really cool, like various brackets and braces and things like that. But he had to do like 3D printing. So yeah, I am entranced. But I also know the way my brain works, which is that I'll do a ton of research, I'll buy the machine, I'll make a bunch of goo gags with it, and then it'll just sit and collect dust. So I need to have like a compelling reason. And what I'll probably do is get the design software, design the things that I need, get them 3D printed from some service. If I'm doing this a lot, then I will actually bite the bullet and get my own 3D printer. Sagittarius A. Are there scientists that mix in a belief of God creator instead of the Big Bang Theory? No. I mean, there can be, but they're generally not taken seriously by the scientific community. Now, there are many scientists who are believers, who are, who have faith in some religion, could be Judaism, could be Christianity, could be Hinduism, like you name it. You name it. There will be people who are adherents to different faiths, but there's a very clear line of delineation between the work that scientists do, where you are probing nature, you're performing experiments, you're using the scientific method, you are moving forward in this way where you are not anticipating or expecting an outcome, versus the why, why are we here? What is the purpose of our life? Why did the universe come into being? What is the moral framework that I perceive the world in? And that there are plenty of people who are religious. I don't think it's the majority, but I would say a very significant percentage. The Vatican has an observatory and has a chief astronomer, and they are actively publishing papers about space and astronomy, contributing to research into the Big Bang even. They see no concern with the science and their religion. And, right now, where did the universe come from? We don't know, right? Why is there something and nothing and not nothing? We don't know. That the Big Bang, and this is a great example. This is something that just, really grinds my gears, which is that people who don't understand the Big Bang and feel threatened by it because maybe their faith in their religion isn't strong enough, or they're worried that other people aren't going to be able to accept the tenets of their religion, will attack things like the Big Bang, and will attack scientists and say scientists are just trying to overturn the Big Bang, try to disprove God. And that's ridiculous, right? Scientists are not trying to disprove God. Scientists are just trying to understand the universe. But the Big Bang says that the universe is getting farther apart, that the things in the universe are moving away from each other. And this is a very simple observation. Like if you have a fancy telescope, you can measure the redshift, blue shift of various galaxies in the universe, and you can tell, like what Edwin Hubble did in the 1930s, you can detect that the universe is moving away from you in all directions. And so if the universe is getting farther apart today than it was closer together in the past, and that you can just do the math. And that's what the Hubble constant tells you. You can do the math with the Hubble constant to find out when the universe was, where the things that you see on the left side of the universe and the things you see on the right side of the universe were once in the same place. That if you take that 70-ish kilometers per second per megaparsec and you run the clock backwards, then you get about 14 billion years. That 14 billion years ago, things on the left, things on the right, they were all in the same place. But that's where the story ends. That's what the Big Bang begins with this expansion, but it doesn't explain where it came from. So when the Big Bang was first developed, it was really satisfying to religious people who believe in some kind of creator that sprung the universe into existence. That God said, let there be light, and there was light. That fits perfectly with the Big Bang. And it's really super weird to me that that people who say they're religious, and this is their explanation for the universe, look at the current understanding of the scientific theory and say, this is against my religion. Because scientists are not saying what caused the universe, where it came from, what was before the universe. They're just saying the universe is getting farther apart. And we don't know. We are unable to probe beyond that first moment. But, and this is important, it doesn't also justify, like there can be, like if there wasn't light, if you hold too strongly to these religious ideals, these religious beliefs, these instructions that were put into a book, that you can come out on the other side and realize that reality is telling you things that are directly oppositional to what the book says. And now you have a problem, right? Either the book is wrong or the universe is wrong. And that is a very uncomfortable place to be for a lot of people. But if you just stay loose, stay flexible, don't take it too seriously, man. Just try to live the best life you can. Have a sort of structure for your life. And when new interesting things are discovered about the nature of the universe, just take it take it in stride and don't worry about it. I think that's a perfectly rational way to sort of mix your belief in a creator with the discoveries that science is making. Bruce, you should see my workout room I never use now. Yeah, it's your it's your laundry rack, right? RMS. If nothing can travel faster than the speed of light, did in the first seconds of the Big Bang, the universe expand way faster than the speed of light. So remember, things can't move through the universe faster than the speed of light, but the universe itself can expand at any speed. And that from your perspective, you could be seeing things that are moving away from you faster than the speed of light. So at the very beginning of the universe, during the inflationary phase, where the universe went through 10 to the power of, I forget, like 30 something doublings in size, went from this primeval atom-sized, well, the observable universe went from this really tiny size to the size of a volleyball in a fraction of a second, I forget what it is, 1 to 30, 1 to the negative 32 seconds, something like that. That how fast was the universe expanding? It all depends on your measurement, right? If you're going to measure the size of a hydrogen atom, then the places on the other side of that hydrogen atom might not be moving faster than the speed of light. But if you're going to measure from one side to the volleyball side, then things are going to be moving faster than the speed of light. So it just comes down to what distance are you measuring? How fast are things receding away from you because of the expansion of the universe? But at no point is anything actually moving in the universe faster than the speed of light. Just from your perception, things are moving faster than the speed of light. Gadzooks, will Elon Musk be sending Optimus? Gadzooks, will Elon Musk be sending Optimus AI robots to Mars this decade? This decade, like in the 2020s, I don't think any SpaceX missions are going to be going to Mars in the 2020s. I know that was the plan, but here we are, 2026. The next Mars window opens up 2028, so that's the last chance, and then you're into the 2030s. So for within the next 10 years, so by 2036, will SpaceX have launched a rocket to Mars? Maybe. But I wouldn't want to put odds on it yet. That still the technology is coming along slowly but surely. We should be seeing the new Starship launch next week, we hope, or the week after that. And that's going to be the new one with the new Raptors, the new V3 version of Starship. But we're still not at full reusability. Like, there's a lot of stuff that still needs to be done. But who knows? So right now, will we see a SpaceX mission to Mars in the next decade? Maybe. Probably. Will we see Optimus robots sent to Mars? Maybe, probably not. Yeah, because then they would have to build the Optimus robots, have a way for them to get out of the Starship that has landed safely on Mars, and walk around and do something until they run out of batteries. Yeah, I would be very skeptical that we would see Optimus robots on Mars within 10 years. But I would love to be proven wrong. That'd be great. Christopher Meyer, are there polar craters on Mars that could be sheltered from the sun while offering solar power like the moon's south pole? Could you elaborate on the strategy? Yeah, so just like the Earth, they're permanently, sorry, yes, just like the moon, there are permanently shadowed craters on Mercury in the same way that there are places on Mercury where the sun never reaches the bottom of the craters. And so theoretically, well, not even theoretically, we know that there is water ice in those craters on Mercury. So you could go to the crater rim of one of these craters, and then you have solar panels, maybe on a large, some kind of tower, some kind of solar tower, so that you're able to get as much solar power as you can above the local mountains. But then you've got your base down in the crater, and you're able to dig water out of these polar craters. So yes, it's exactly the same situation on Mercury as there is on the moon. The incredible thing about being on Mercury is that you have a lot more energy from the sun. You're closer to the sun. Solar panels work much better, more efficiently. So there's some pretty good reasons to go to Mercury, and it should just be explored more. It is the hardest planet to get to in the solar system, and so anytime that we could spend there understanding the composition of Mercury as a totally different planet, than Mars, than Earth, than Venus, would be great. Take Krebs, could there be another Big Bang or a new one growing? So it all depends on how the Big Bang happened. So, one of the ideas for the Big Bang is inflation, that early on there was some kind of runaway process that caused the universe to go through this rapid expansion and get very big very quickly. But if inflation is true, then this was a process that was happening across the entire actual universe. The different regions of the universe were expanding very rapidly. And in some places it stopped billions of years ago, and it might be in other parts that this inflation process is still happening. And that theoretically the universes that are growing in other parts, or the regions of space that are being inflated and expanding, are spatially connected to the universe that we live in. And so you can imagine some theoretical possibility where the two universes will overlap with each other, and that you will have essentially nonsense physics going on in this overlap, this Gantt chart. What's it? Gantt? No, it's what do you call, is it Gantt? Where you have overlapping circles. Yeah, so you've got this overlap of universes where the laws of physics are a little bit of one universe and a little bit of the other universe. And that would be very hostile to life if we happen to be in one of those places. So this is one of the expected outcomes of the inflation idea. It's called continuous inflation, continual inflation. So that's one possibility. The other possibility is that, we don't know really what were the initial conditions that caused the Big Bang. Why does our universe, right? Where did our universe? And so could those conditions happen again? Could you get some other, there you go, it's a Venn diagram. Yeah. Could you end up with some other version of the universe appear within our universe, that if it happened once, maybe it can happen again. Maybe it won't happen soon. Maybe it can happen down the road. And you can imagine that another universe would appear inside this existing universe. And then same thing, you would end up with this Venn diagram overlap of the new universe that is forming inside the old universe, and the laws of physics are getting turned into nonsense during this time. So, we don't know. We don't know what were the conditions that led to the universe that we find ourselves in. And so we don't know if the preconditions for this Big Bang, this universe that we find ourselves in, are here in this universe. Whenever you think about the universe, and this is a problem not just for the scientific thinking about the universe, but even just religious thinking about the universe, right? Where we can roll the clock back in the universe back to the very beginning, to to fractions of a second after the Big Bang, after the expansion began, after the weak force, or after the strong force broke into the weak force and the electromagnetic force, however gravity was tangled up with those other, we can go right back to that moment where the entire universe was like this cork glue-on plasma. But then we can't go any sooner. We can't go any earlier than that. There is no sort of theoretical place that we can go. But where did it come from? Right? Like there's two possibilities exist. Either the universe was always here forever, or the universe appeared. And then if it appeared, what was before it? What caused it to appear? And, the flippant, the religious may say, well, God made it. And you're like, okay, fine, but where did God come from? But like that. And they're like, well, you don't need, God was always there, always eternal. Yeah, but you can't, like, really? Like you go all the way back, you need to have a first cause, and then you have God, and you're like, where did God come from? Oh, you don't need a first cause. Well, that doesn't make sense. So no matter what you do, the universe that we find ourselves in is puzzling, because we are always trying to think, well, yeah, but what caused that? What caused that? What caused that? And so we may never figure out, we may never get to the bottom of where the universe come from. And you can take this, like, think about simulation theory, that, the universe that we live in isn't real, that it's really just a simulation that's running on some computer. Okay, fine. And that if you could get out of the simulation, you be in that level up, and you're in this new universe, and it turns out these are the actual laws of physics in this new universe, but maybe they're running in a simulation, right? Maybe they're running in a simulation, and then maybe they're running in a simulation, and simulation's all the way down. But somebody has to be in base reality. There has to be a base reality to have created the first simulation. And that universe, where did it come from? And what came before that? Like, you can never get away from this question of where did you come from? The other idea that I really like is the far, far future. That, if we live in an infinite universe, then the random configurations that are possible in the universe will eventually give you another universe, that you will eventually, in an infinite amount of time, assemble a new universe. And you'll do it an infinite number of times. So if the universe will last for infinity and is infinite in size, either one, infinite in time or infinite in size, you will get other versions of the universe just as a natural outcome of that, because infinity is mind-blowing. Back to the sort of the philosophy of this, this whole idea, was it Descartes? I think therefore I am, right? That it's such a simple truth that I am experiencing the universe right now. I have consciousness. I'm sitting here in my office, looking into my camera. I see my microphone in front of me. I feel my watch on my arm. My arms are crossed right now. I can feel my chair. I'm thinking about the questions that I'm being asked. I am contemplating my existence. I perceive, I have consciousness. So this thing I know is real. If I could be a brain in a vat, I could be living in a simulation, I could be, it doesn't matter. I exist, and I assume you exist, right? I can't be certain in the way that you can't be certain that I exist, but still. So there has to be something. There can't be nothing. There is something. There's the thing that you can hold on to is the recognition of your own consciousness and your own existence. And so that kicks off the whole chain of what was before that? What was before that? Where did it come from? Who knows? And we may never know. Like, that's the part that you've got to be okay with. And I think that really defines the line, where there are people where it makes them feel so uncomfortable that getting a nice simple answer, God did it, whatever, is very comforting. But I don't think that is the best answer. The best answer is we don't know. It might be that we are created, but then you've got to ask the question, where did your creator come from? Might just be that you have to just sit in this discomfort, this dichotomy that I perceive the universe, I have consciousness, and yet I don't know why I'm here, where I came from, where I'm going, what is the point? And even if I can figure those things out, what were the conditions that led to that before that? It is turtles all the way down. And it will drive you bananas. Super Luigi Daisy. Wait, are you talking about the I have no mouth yet I must scream story about the AI that got globally mad and all? No, I'm not talking about Harlan Ellison's wonderful story, I have no mouth yet I must scream, but it is a terrifying, horrifying story, if you've got the stomach for it, to read it, about a very, very angry AI who is taking out its frustrations on the remaining human beings left in the cosmos. And there's a new show on Netflix that I'm watching with my kid, and I forget what it's called. Oh, Netflix, something circus. It's called The Amazing Digital Circus. Okay, so there's a show on Netflix called The Amazing Digital Circus. You can watch it on YouTube, I think, as well. And it is a homage to I Have No Mouth Yet I Must Scream. And it's good. I'm enjoying it very much. It's not as horrific as it could be, as it should be, when you really sort of think through the essentially this woman is in this animated world and is sent on adventures by a taskmaster crazy person and a bunch of other people, and they kind of don't remember their pasts and their histories. It's really good. I don't want to give you any more information about it. Yeah, check it out. Idipograph. Do you believe humanity will ever uncover the theory of everything? Travel faster than light. Hack this simulation. We don't know. We don't know. We don't know what we're going to discover in the future. I mean, you go back 100 years, 200 years, and you think about the potential discoveries that we were going to make in terms of electronics, in technology, in communications, electromagnetic spectrum, quantum mechanics, medicine, biology. It goes on and on and on and on and on. And if you sort of sat down with a scientist in 1826 and said, okay, here are the things. Like, give me your questions and I'll answer them, and I'll tell you the kinds of things that we have in our world. Like, not only would they be surprised at the things that exist, they would not have been prepared for the kinds of things that could exist. They wouldn't, like, it wouldn't even have occurred to them on what could have existed. And so right now, obviously, we feel that there must be some kind of theory of everything. There should be some way to unite gravity and quantum mechanics. And that if we just do that, then we will understand the universe a little bit better, and probably will. You know, this Einstein took this to his grave trying to figure this out. There is an answer. I mean, we can perceive the effect of gravity. We can perceive the effect of quantum mechanics. Now kiss, right? There's got to be a way that these things can work together, and it's just a matter of us doing better experiments. You know, the problem is coming along. It's more difficult than we thought. But and so I do think that we will eventually figure that out. Will we travel faster than light? I don't think so. That is something that appears to be the speed limit of the universe. And there's all kinds of paradoxes that happen if traveling faster than the speed of light is something that actually could be uncovered in the future. Hack the simulation. That's a really interesting one, where we wonder, could we figure out, could we do something that would help us figure out if we are indeed in a simulation. Could we do something where, the computer can't render fast enough to keep up with us? And then we'd be like, okay, we are living in a simulation. If so, how do we hack this simulation? That would be scary. It's a terrifying idea. Fascinating. But there's no reason to believe that we actually live in a simulation, unfortunately, or fortunately. So you have to live your life as if this is base reality. And so don't take any stupid chances. Church discography. Do you have tickets yet for The Mandalorian and Grogu? No, I don't. And I wouldn't go see it in the movie theater. I would wait for The Mandalorian and Grogu to show up on Disney Plus, which I've canceled. So I'd have to wait for the time in the future when I'm going to re-enable Disney Plus for 1 month, gobble up all of the Disney Plus shows that have been made in that 1 month, and then shut it back down again. I honestly don't love The Mandalorian. I love Andor. Andor is one of the greatest science fiction shows ever made. Up there in my top 5, for sure. Invincible, Pluribus, Andor, Stargate SG-1, Love, Death, and Robots. Those are my top 5, I think. But no, I don't love The Mandalorian. I find it a lot of the Disney Star Wars stuff is terrible. Oh. Blasphemy, I know. Frosty Winnipeg. What is the temperature of those Mercury craters always in darkness? I forget. Let me just see. I'm going to guess it's negative 230. Let me see. See what the temperature fluctuations are. So it is minus 193 Celsius at the poles. So it's off by a bit. So the coldest temperature of the poles is negative 193 Celsius, which is very cold. But the maximum is 106 Celsius. So hot enough to boil water, cold enough to only be a little bit above, well, I don't know what it is. Freeze hydrogen, liquid nitrogen. I don't even know what you can do at negative 193. The Sky Dreamer, is the space expanding or are we going smaller? It depends on how, on sort of how you ask the question. So if we are getting smaller in a way that is consistent across, that in everything, that our atomic bonds are getting smaller, the force of gravity is adapting to get smaller, that everything, the electromagnetic spectrum, the waves are getting smaller, that everything is perfectly getting smaller, then it is indistinguishable that things are moving away or we're getting smaller, right? As if you are thorough, but it is the opposite of Occam's razor, right? You just say, you've got two cars and they appear to be driving away from each other, or maybe the two cars are just getting smaller and every part of the cars are getting smaller. Probably they're just driving away from each other. Dougal, how many rocket launches have you been to? I've been to one successful rocket launch and one delayed rocket launch. So I went to go see the second to last launch of the space shuttle in 2011. And this was kind of special. So my father is a giant space nerd and was, he watched the moon landings live. He was really excited when they brought back the space shuttle in 1981 and woke me up at like 5 a.m. so that we could watch the launch of the space shuttle. And And so when I became a journalist in 1999, he was really excited about it, and he would tell me, "Oh yeah, I'm watching NASA TV right now. The floaters are on." That's what he calls the spacewalkers. And he's a photographer, so that was his day job back before he retired. Was he took photographs, really good photographs. He's sort of like the archivist for the island that I come from, but has was in the newspaper and won a bunch of awards and was part of books about Canada and stuff. So he's like a really good photographer. And so I booked a trip 2011 to go see the second to last flight of the space shuttle, Endeavour, and had my dad be the photographer for that trip. And so we went together, and we went down to Kennedy Space Center, got our press credentials, went to the press office, went to the vehicle assembly building, went and did the tour of the Kennedy Space Center, went out and saw the space shuttle on the pad. It was incredible. And I was sort of doing my reporting, and Dad was taking a bunch of pictures. We got lots of pictures that he took of the trip. And then they delayed the launch by a month. And so we didn't know at the time. They delayed it for a week, and we had about 2 weeks for our trip. And so we went down to Miami and then came back, and they had delayed it for a month. And so our flight had to come back. We had to come back. We couldn't just loiter around Florida for a month. And so we had to come back. So that was the flight that I went that I didn't see. And that would have been so great to take Dad to see a launch of the space shuttle. And then the second launch that I saw was the launch of OSIRIS-REx in 2017, 2015. God. So on that one, my wife is a photographer. And so she did the photography for this mission, but also I brought Chad, who's the video editor for this show. And so me, Carla, and Chad went to Florida, and same thing, got our press credentials, saw the vehicle assembly building, went and did the tour of the Kennedy Space Center. We saw the exploded launch gantry for SpaceX when they had the helium explosion on one of the SpaceX rockets. We drove right past it. It was just this sort of wreckage. Went past the Blue Origin's facility, which was really cool. And then we set up shop we got a really nice location to watch. It was an Atlas rocket. We were across this, bay to the launch facility, and we watched the rocket take off right on time. And it was incredible. It was amazing. I highly recommend it. If watching a rocket launch is a thing that's on your bucket list, it is a very straightforward thing to accomplish. That all you have to do is go to Orlando, which is where Disneyland is, right? Disney World. Like there is a lot of places to stay at Disney World or in the vicinity. Lots of flights take you to Orlando. Very easy to rent cars in Orlando. And then you can either go from Orlando. It's about an hour drive to go from Orlando out to Titusville, out to where the Kennedy Space Center is. Or you can stay in Titusville or Cocoa Beach, which is the beach that faces the Kennedy Space Center. And so you can get a hotel, and they're reasonably priced, and you can sit out on your hotel balcony or sit down on the beach while the kids are making sandcastles, and you can watch a rocket just take off. And the view is good. Like, it's not quite as good as we got from the press viewing area, but it's really good still. Watch rockets take off. You could have watched the Space Launch System take off. So it's not that expensive. The downside the downside when I first did it was that the delays can be killer. And then you could, because they're only launching a couple of rockets a month from the Kennedy Space Center. Well, now they're launching them every couple of days. Sometimes they're launching them back to back to back. And so your chances of actually watching a launch happen are really good. It might not be the launch you were hoping for. You might not watch the Falcon Heavy take off and then see the twin boosters land side by side at the Kennedy Space Center, but you should be able to see a rocket if you're there for a week, say, and keep yourself entertained in the area. So highly recommend If you want to knock a thing off of your bucket list, go to Florida, go to the Kennedy Space Center, watch a rocket launch. Obviously, you know, maybe wait until you want to go back to the US if you're not from the United States. But apart from that, yeah, it's totally worth doing. Tool, have you ever woken your kids up for a space event? Nope, not. But I have said the message saying, oh yeah, the space launch system is about to launch. And they're like, okay, Dad, whatever. These were one tier. No, my kids are into space. My kids are super into space. I did a cruise out of the Kennedy Space Center with them, or it was out of Miami, Fort Lauderdale. Anyway, and so I took them with me, and so they got a chance to see the Kennedy Space Center as well. So they've seen the space shuttle. They've seen 2 of the space shuttles at this point. The street pane. Is the universe expanding into something unknown? So the universe is just expanding. The best way to describe it is the universe is getting less dense over time. And one possibility is the universe is infinite. And so it's just getting less dense. Things are moving farther away from each other. And if you went in any direction, in infinite distance, you would just arrive in places that kind of look like the universe that you came from, right? You're going to see galaxies around you. You're going to see stars. You're going to see planets. You're going to see distant galaxies. And the galaxies are going to be moving away from you in all directions. That's one possibility. So that is not moving into the unknown. It is just that the place is getting less dense over time. The other possibility is the universe is finite, that it wraps in on itself. And so still, it's not moving into some unknown. It is just becoming less dense over time, but it is a finite volume that is doing this. Daniel Whitehouse, do you think those blow up modules would work on the moon? Yeah. So this is an idea that has been tested in space. There's a module that's attached to the International Space Station that was developed by Bigelow Aerospace back when they weren't bankrupt, which was this inflatable. It's called Beam, the Bigelow. I forget what the acronym stands for, but it is an inflatable module that's attached to the International Space Station. And Bigelow had been developing versions of this that could be much, much bigger, where you would have, say, the volume of the International Space Station that could be inflated, but it would just be one launch. Lockheed Aerospace, Lockheed Martin has also been working on versions of this, where you essentially send up there's the central core part of the station that fits within maybe within a 9-meter fairing of, say, Starship. And all of the electronics and the computers and the airflow systems and the bathrooms and cargo and all that is inside this sort of central cylinder. And then the outer part of the inhabitat can inflate and you end up with this torus. And this has been an idea that's worked as well. And so people have considered if you could build these inflatable structures on the moon, that you could build, say, a hemisphere on the moon that you would inflate. And theoretically, this would work just fine. In fact, there was this potential idea for a rescue on the moon that was proposed back in the 1960s, that if astronauts were stranded on the moon, that they maybe should take some kind of inflatable tent for the moon. And that if they run into any problems, they can inflate the tent on the moon. They could survive for a couple of weeks so that a rescue could be mounted to bring them back home to Earth. So yeah, no, the inflatable modules theoretically should work well. And I would be super surprised if the first permanent station on the moon isn't made out of inflatable habitats. It's a great idea. Dan Chebby, do you think that our knowledge about the real universe is just a fraction, or are we pretty close to knowing the core things and only stuff like dark energy are left to figure out? This is a great question. And, this is a question that Sean Carroll gets a lot. So, we know, I'm going to sort of try to give the kind of answer that Sean Carroll gives, which is that we generally know in broad brushstrokes the way the universe works at the largest scales. We understand gravity, we understand quantum mechanics, we understand chemistry, we understand particle physics, we understand motion and energy and momentum and entropy. All of these basic concepts in physics, we understand them quite well. And it would be very surprising if we thought that energy was this, but it's actually that. We thought entropy works this way, but it actually works that way. Like, those kinds of big discoveries are probably not in our future. It's going to be continuing to refine the discoveries that we've already made. There are going to be huge chunks of the universe that we don't understand, and this will keep us busy for millions, if not billions of years, if we happen to survive. But I think you could, a million years from the future, you could explain some concept in physics and bring a physicist of today up to speed on what it is that you're working on pretty quickly, as opposed to just like, I don't even have common ground. I can't even explain. Like, how there's a glorp? No, you don't have glorps yet. It probably wouldn't be that. Nunya, what is the current best theories for extracting ice on the moon for a base? Yeah. So that's a great question. And we don't really know yet. There have been a lot of really interesting mission concepts that we've reported on Universe Today over time on how you would do that. Because you're going to have to send a rover or some kind of lander or something into a place that has no solar energy. And you're going to then have to use a ton of energy to be able to extract the water ice that is there. Whether you're just going to be digging it out and then transporting it back outside of the crater to your base where you're doing your processing, or if you're going to try to do your processing on site and then extract the water and separate the oxygen and the hydrogen and then bring that back, that is still an ongoing challenge. So there have been a lot of ideas about this. The one idea is that you would have some kind of power beaming. So you'd have, say, towers that are around the crater that you're going to be working in. And then you're going to have towers that are beaming down energy, lasers or whatever, at some kind of rover, some kind of excavator that is going down into the crater to be able to pull this material out and bring it out. And then you can deliver it to some production site that's in full sunlight that has lots of energy. The other possibility is that you're going to have to run cables, tethers, things down into the crater to be able to operate this. There's also been some ideas about conveyor belts. So think about Factorio. So there was actually a recent request for proposal. I forget the company that sent it in, but essentially to do logistics on the moon for NASA as part of their exploration of the South Pole of the moon. And so they would set up conveyor belts down in the moon where they would transport material, regolith and so on. And getting that last mile into the crater to be able to extract that material is going to be the tricky part. It won't look like, you're probably going to have battery operated excavation tools. Think about a front end loader that's going to be able to go down into the crater, chip away at the ice for as long as this battery pack can survive, bring the material back out, dump it, recharge, but it is going to be significant engineering challenge, because you're in this place that is really hostile to work at. There isn't a lot of easily accessible energy for you to be able to work with, and yet you're trying to do something that is very energy intensive. It is going to be a significant challenge, and that's why, we're going to see it be decades before we're actually harvesting these resources. We are purely in the exploration phase right now. Raby, do sand dunes on Mars migrate? And if so, is there any danger they could cover a rover? Sand dunes definitely migrate on Mars. And it's interesting because the physics on Mars are different than they are on Earth. The air pressure is 1% what it is on Earth. So the amount of energy that the wind can throw into the sand grains is different. But the force of gravity on the surface of Mars is 1/3 of what it is on Earth. And so sand dunes can be a lot steeper than they are on Earth. And there's some really interesting math that's been done. People have compared what the sand dunes look like on Earth compared to Mars, compared to Titan, because there are sand dunes, or I guess the sand is made of water ice, of dust, but it's water dust, ice dust. Anyway, so you can actually compare the formation and the interaction of dunes on different worlds across the solar system. But, we know the dunes form. We know that they shift and have shifted in the past. But it doesn't happen on the scale that a rover would be driving by and would get caught in a Martian sandstorm and it's going to be covered by sand dunes. But there could be a collapse, or could be some kind of landslide that would happen above a rover. And so these are the kinds of surface conditions that the rover drivers take into account when they're exploring the surface of Mars. I mean, they are really, really careful about it. They look at the conditions of various sand and go, oh, that's a little dicey. I don't want to try and send my spacecraft down. I don't want to send the rover down that slope because it might get caught. And there've been lots of times where the rovers have almost gotten caught or have gotten a wheel caught. It's been kind of touch and go sometimes. So they're very, very cautious about this. But there's also, and we talked about this last week on the question show, there's places on the moon where they're right at the edge of having a landslide, that there are places of fresh landslides on the surface of the moon. There are places where rocks have rolled. You can see the trail of the rock as it's gone downhill, down the inside of a crater. And so if you've set up down at the bottom of a crater on the slope and there's a tiny little moonquake in your area, or just something causes the side of the crater to shift, you could get a landslide coming down and landing on top of you. And so when we do have explorers on the moon and they're in a crater and they're near the crater rim, down at the edge or along the top of it, I promise you, people back in mission control are going to be like, watch out, be careful, keep your eyes up, don't get too close. Are there any boulders that look like they could fall? These are the kinds of hazards that they really don't want to face. Seth Levine, should we be using low Earth orbit with centrifuges to study low gravity effects of 1/6 or 1/3G on people? I'm kind of torn on this. I think, in the past, I've been quite excited about the idea of using centrifuges. And in fact, there was a component that they were thinking of adding to the International Space Station called the Nautilus X. And what this would be this rotating module on the International Space Station where the astronauts would go and lie inside of it, and then it would spin them up at some rate so they would experience some level of gravity. And this would allow us to learn, we know that microgravity is really bad for the human body, but if we do spin up the astronauts at some speed, will we be able to remove some of the downsides from the astronauts? And the module was going to cost like $4 billion. And in the end, NASA canceled it, which was too bad because I thought it would have been really great. So I think trying to understand what's going to happen to the human body on the moon or Mars is probably not worth the research. That the thing that you do is you send humans to the surface of the moon, which is 1/6 gravity, And that will tell us if, eventually we'll build a base on the moon. They'll be there for a year. We'll see what happens to their bodies. That'll tell us whether or not being on the moon for that length of time is good or bad for the human body. And that if it is fine, like now suddenly all of the problems that we know happen in microgravity, if those all go away when you're on the moon at 1/6 gravity, then that's probably fine for Mars. That you can go to Mars at 1/3 gravity, and that's better than 1/6 gravity, and so it's probably also going to be fine. The thing that we need to figure out is, I always say that gravity wells are for suckers. That why would you go down into a gravity well when you went to all the effort to get out of a gravity well in the first place? And so living in space itself, in some kind of space station, is probably going to be the way. And if you're going to want to do long trips between Earth and Mars, Earth and Titan, whatever, we're going to need to learn to build artificial gravity into our spacecraft. And that's where the centrifuges really come in. And this is an idea that's been proposed. If you watch Project Hail Mary, if you watch The Martian, they have really cool spacecraft that have artificial gravity. This has been tried out in various different space shows. It was in Babylon 5. The Earth spacecraft have rotating components that provide the gravity. So that is one of the big challenges that we experience in being out in space itself. And so that's why I think we need to solve this problem. We need to, if we want to live in space, which we eventually do, we need to overcome the lack of gravity, the dealing with the radiation, the need for a closed environment. Each one of these is an engineering challenge on its own. But to research what's going to happen to a person on 1/3 gravity, 1/6 gravity, just go to the moon. It's right there. Warbeard Jr. I just got a notification that I need to be polite and respectful to comment here. Have I ever been disrespectful? Have I ever been a smart aleck? Maybe you should answer that. I don't know about you specifically, but in general, we have a great community here. And, I think it all comes down to the fact that we ask everybody when they arrive to be nice, to behave, to be friendly. That's it. That's all that's required. And all the trolls and all the assholes, they just don't show up. So don't take it personally. This wasn't meant for you specifically. It's not like we remembered how you behaved in other live streams and on those other channels, and the thoughts that you have when you think that no one can tell that you're thinking those thoughts. We know. But yeah, it's not you personally. Just in general, just like, don't be an asshole, man, is the thing that I would say to everybody. Like, just in general. Like, it's weird that we have to make a sign for it. Shouldn't we all just be able to get along? But maybe that's just the Canadian in me, being polite. King Tad, Fraser, regarding cremating an asteroid on... King Tad, Fraser, regarding cremating an astronaut on Mars, how would they accomplish that in the atmosphere? Oxygen, fire on a rover, night before the others leave, or something else? No, they would have to have a special device that is able to cremate, where they can deliver the oxygen and whatever is the, whatever is doing the combustion. You need, think about the fire triangle, right? So they need to be able to deliver the oxygen too. But you can pull oxygen out of the Martian atmosphere. You can pull it out of the regolith. Oxygen is going to be pretty easy to get your hands on Mars. The thing that's going to be hard to get your hands on is hydrogen. Hopefully, if you can find water, then you can break it apart into hydrogen and oxygen. But it's going to be pretty tricky to find hydrogen. So we might have to take hydrogen with us to Mars just to be able to make propellant or water or things like that. Or you go and you set up shop on the ice caps on Mars, and then you've got all the water that you need. Casey Villain, are astronomers able to deduce anything about the interiors of exoplanets? And if so, what observations inform what we know? Currently, no. So the observations that you can make of an exoplanet, you have kind of two main methods of observing exoplanets. Detecting their presence. So you can do the radial velocity method, which is where you measure how much the planet's gravity is pulling the star back and forth. And that gives you the mass of the planet. And then you can do the transit method. And that's where you're watching the light from the star dim as the planet is passing in front. And that allows you to measure the radius of the planet. Once you know the radius and the mass, you can determine the density. And the density tells you what the planet has to be made out of. So you can have planets. There's this whole new class of planets that have been discovered called super puff planets. And they have a density that is lower than Saturn. They have densities that are much lower than water. I forget what the least dense super puff planet is. Now I want to look it up. Hold on. So they can have a mass of the Earth, but have a radius bigger than Neptune. 0.1. So the three planets around Kepler-51 are all Jupiter-sized, but with densities below 0.1 gram per cubic centimeter. So if water is 1 gram per cubic centimeter, they are 1/10 the density of water. So you can determine the density of a planet. If the planet has the density of water or the planet has the density of iron, you can determine that. We know what the density of Earth is. It's 5-ish grams per cubic centimeter. It's a little bit higher than Mercury's density. And so you may find a planet that's a super puff planet, or you might find a planet that is roughly the density of water, or you might find a planet that has roughly the density of metal or rock and metal. And that will inform you about what that planet is made out of. Now, you won't be able to tell the internal composition of the planet purely from that. The only way that you can learn about the internal composition of a planet is to do some kind of seismometer on the planet. So you need to literally put a seismometer on the surface of the planet, listen to earthquakes or exoquakes that are happening on that planet. That will allow you to see how seismic waves are moving through the planet, passing through different layers in the planet. And then you can go from there to determine, here's where the solid core begins, here's where the liquid core begins, here's where the whatever, right? We can't do any of that right now. So all you can do is make a rough estimate. And this is why there are some controversies about certain kinds of planets. That think about this sort of new class of planets, these Haitian worlds. Haitian? Yes. Ocean, yes. Okay. Think about these Haitian worlds where they seem to have a thick layer of water surrounded by a hydrogen atmosphere. Well, that was determined by the density of the planet. That you can take the density that you get of this planet and you can mix and match it to give you this amount of solid, this amount is water, this amount is hydrogen, or this amount is solid, this amount is water, or this amount is solid, this amount is just the surface, just rock, and maybe has a very thin atmosphere. That you can kind of mix and match the planet in different ways and come up with different outcomes. And that it's going to take direct observations of these planets to sort of put the final piece together, where we've used the radial velocity method so that we know the mass of the planet. We've used the transit method, that tells us the size. And then we use, say, the Habitable Worlds Observatory to directly observe the planet and look for chemicals in the atmosphere of the planet. Do we see water vapor? Do we see the glint of oceans? Do we see the red edge of plant life on the surface of this world? Are we seeing volcanic gases? Are we seeing volcanic activity? Are we seeing infrared, the heat of lava lakes on the surface of this planet? So there's going to be more observations, and then you can again reverse engineer from what we know. And then you can reverse engineer about what we know from planetary geology and get you to this place to understand what might be inside that planet. But this is going to be really tricky work, and there's going to be a lot of arguments. We see these arguments already where someone says, that's a super Earth. No, it's not a super Earth. It's a sub-Neptune. And we may never easily be able to find out to distinguish between the two. Web Fiji. I'm a coder with multiple AI coding tools at my disposal. What is something impactful I can do for astronomy and space community? Well, I think the opportunity right now is to do things with the Vera Rubin data. So I did an interview about a month back, 2 months back, with one of the data brokers, the people at the Antares project, which is part of the Noir labs. And there's like 7 different data brokers that are pulling material from Vera Rubin, packaging it up, and then people can code APIs into it. There's Think, which is the one that's specializing just on solar system objects. So you can find asteroids, comets, Planet 9. And then I think the thing that would be most useful would be talking to astronomers, or just like looking in discussion forums where people are talking about things that they really wish existed, and then make one of these things that you can develop an API, that you can develop your own interface that accesses the API from one of these data brokers and allows you to do various interesting visualizations and alerts of things that are happening out there in the cosmos based on Vera Rubin data. I put out a call last week for people to tell me about their projects. I've gotten a bunch of people have sent them in, and I will definitely be giving some cool shout outs to interesting projects that you can try out. But just 700,000 things are happening every single night, according to Vera Rubin. It's too much for us to be able to understand. Someone has to sort and filter and turn that into something that you can wrap your mind around, that people can go online and they can just watch this cool globe of the cosmos and see supernova going off around us in all directions, and get a sense of this active universe that we live in. So I think that's the kind of stuff. So build something cool using Vera Rubin data that lets regular people understand and put into context the amazing stuff that's happening out there. And if you make something really useful, you will probably attract the attention of astronomers, and they'll give you tweaks, and they'll ask for features that will make, them able to do more research. So yeah, it is such a cool time, a fertile time to build these kinds of tools. Big data. We are now in the era of big data. And you can do things with Gaia data, with Euclid data. Like it's unlimited. The new dark energy survey is done. The dark energy spectroscopic instrument just released their new survey. There's so much out there, so much data that people need to be able to go through. Arjun, so is the moon supposed to become the new International Space Station, meaning there will eventually always be a group of astronauts doing experiments on the moon instead of in orbit? Well, the hope is that we will have both, that we will have a group of astronauts in orbit around the Earth at the International Space Station, or some version, like obviously the ISS will eventually come down, but there will be some version of a space station. Then there will be a permanently inhabited base on the moon, and there will be astronauts there, and you can like look up at the moon and know. I mean, it's really incredible that from when the International Space Station was launched until now, like it was 1999, Here we are, 2026, closing in on 30 years. There have always been people in space. Is that amazing? And so we will reach this point where there will always be people in space, in orbit, and there will always be people on the moon, and there will always be people on Mars. And then eventually there will always be people at Asteroid Station Alpha. And that'll just be incredible. So yeah. I think we've we've reached the crossing point. I think the technology, people always ask, like, why didn't we go back to the moon? Like, after we went there in the 1960s and 70s, why didn't we go back? We didn't go back because it was too expensive, because we didn't have the technology, that priorities had shifted, and it wasn't the kind of thing that you could just fund and get on with the other things that were going on at the time. Now, even in a relatively small budget for NASA, something in the $25 billion range, if spent well, can allow you to do exploration out into the solar system. And so it's just, we're seeing the rise of reusable technology. We're seeing the miniaturization. We're seeing international collaborations. There's just like a lot of cool things are lining up all at the same time together to make this work. Man, thirsty. TCAR925. How much light illuminates the dark side of the moon? Where is it coming from? I forget the exact amount. So the first thing is to remember that, we always talk about the dark side of the moon and the far side of the moon. So, the side that we can see is the near side of the moon, and the side that we can't see is the far side of the moon. And that is because the moon is tidally locked to us. And when people talk about I'll see you on the dark side of the moon, sometimes the dark side of the moon is the side that we can see, because the moon is going through its 28.5-day cycle where it goes from light to dark, dark to light. And so when we're seeing a full moon, the light side of the moon is the near side of the moon. When we're seeing a new moon, then the dark side of the moon is the near side of the moon. When we're having, the parts of the moon that are dark, they are illuminated, and they're illuminated by the Earth. And this is a thing called Earthshine. And this is that essentially the light is coming from the sun, it's reflecting off of the Earth, and it is illuminating the moon. It is allowing us to see features on the moon when it is in shadow. And there's this incredible photo of the Artemis 2 mission where the astronauts took a picture of the Earth while the Earth was in shadow. It was nighttime on Earth, and yet it was being illuminated by the reflected light from the moon. And so you could see the continents and clouds and all of that purely from moonshine. Let me see how strong Earthshine is. I don't know the number. So 0.15 meters per 0.1. So Earthshine is a calculated maximum apparent magnitude of minus 3.69 as viewed from the Earth. Okay. So the moon, like normally the moon's magnitude is like minus 25. Let me see. So normally the moon's magnitude, is minus 12. Okay, the sun is minus 26. Okay, so the magnitude of the moon is minus 12.74. And that's when the moon is full. And that can change, right? Like depending on whether the moon is closer or farther to us in its orbit when it hits full moon. And so the new moon, the reflected light from the Earth is magnitude minus 3.5. And that is very bright. When you think about you can see down, like the magnitude system goes negative number. This is so weird, but it's negative numbers to 0, and then goes to positive numbers. And so you can see with your unaided eye in perfectly dark skies down to about magnitude 6. And I think it's like every 4 increases in magnitude are 100 times as bright. So if you go from magnitude 6 to magnitude 2, it's 100 times as bright. From 2 to -2, which is very bright. Yeah. And so, man, it's so complex, but essentially it is very bright. That -3.5 is an extremely bright object. Venus is -4. So the new moon is almost as bright as Venus. It's as bright as Jupiter, but it is expanded into the size of the moon as opposed to this very bright point-like object. But you can read when Venus is up at -4 point something, 4.4. You can actually like read text on a book. No, you can't read text. Sorry, you can cast shadows. So when Venus is up, you can cast shadows. Okay. I think we're going to wrap this up. So, a point of order, which is that we're going to be, I'm going to be going to Japan, traveling again, May the 12th, and then back on the 27th. So I'm not going to do any live streams while I'm in Japan. I will still be doing Space Bites while I'm on the road, and I'll be recording introductions to the question shows while I'm in various cool spots in Japan, if I can, if the noise isn't too terrible. But I'm going to be doing one more live stream. That'll be the one next week. So let me just look at my calendar. The 11th. So I will be doing the live stream on the 11th, and then that'll be the last live stream that I do for until the 1st. Yeah, to the 1st of June. So just keep that in mind. But we've got lots of cool stuff still coming out. Hopefully you'll barely even feel it. All right. Thanks, everyone. And thanks in advance, Chad, Anton. You're going to have to deal with this nonsense. Thanks to the moderators. I know Arjone and Zapfan were here. Thanks, guys. And we will see all of you next week. Thanks, everyone.